Okay, so let's get started. We're going to be taking a look at working with our Quick Tune feature found in our Link G5 and G4X programming. Our Quick Tune feature is going to allow us a quick way to calibrate and tune our main fuel table, whether we're going to be in model or traditional mode. You can think of this as an auto-tune type feature. It's different from the mixture map that we cover in the last training module because this is done live as you're actually driving and running the engine, versus with the mixture map, you actually capture a data log, you play that back, you go through the mixture map feature, it'll pinpoint through the data log certain areas that you drove through and then allow you to update the table based on the log data. The Quick Tune is in real time, you're actually driving with it starting to work. Now you can use this in a manual mode or an auto mode. We'll go over how to set this up and how to use the Quick Tune feature. It is probably my more heavily used feature in terms of calibrating the fuel table if I'm on a chassis dyno compared to the mixture map. The mixture map works great if you have log data, you're not live. Let's say you're doing some remote tuning with someone and you're having them drive the vehicle and you're not present. That's fine, that has its place. But the Quick Tune feature, if you're actually calibrating and tuning live with the vehicle, in my opinion, is the way to go if you want to have an auto tune type function utilizing the Link system. Now, one thing about the Quick Tune feature is that we have to be in open loop conditions. We cannot run the engine in closed loop and allow the Quick Tune to actually function. It's going to be essentially taking the place of the closed loop correction. It needs to see the actual raw lambda value from our wideband and not being scaled or skewed by the closed loop correction. So the closed loop has to be turned off to use the Quick Tune function. So it does work fairly quick and it does start to map out the fuel table fairly well as long as we have our settings configurations right for working with a Quick Tune. What I'm going to do right now is jump over here to the closed loop fuel and I'm going to turn it off for the moment and just disable this. So we're going to go up to the lambda mode and we're going to just simply set that to off right now so that we can jump back in here and really take a look at the Quick Tune. Now we can access the Quick Tune feature by either going in our drop down under tuning and then Quick Tune, or simply toggling F12. That'll bring up our Quick Tune menu. So what I'm going to do is just access it from right here, the Quick Tune menu. Now we have this little window that opens up, and what this is going to do is show us in this very small little window the measure lambda from our lambda sensor and then the target coming from our target table. Now we do want to have our target lambda table already sorted out before we do any actual fuel tuning. We've talked about how to do that and what are appropriate values to place in our target lambda target air fuel table, again, as we start to build our base map. So that should already be taken into account. We don't have to worry about having correct lambda target table values. Now, we can go here to show settings so we can take a look at a few different things. Let's go to show settings. If we pop in here, we're going to find Quick Tune settings, fuel table. We can either use the Quick Tune to tune fuel table 1 or fuel table 2. Almost always we're going to be on fuel table 1, so there isn't another option for a fuel table 2. Unless you enable it, then you can use it from your drop down here. The measure wideband source. We can see lambda 1, lambda 2, or lambda average. So in my case, I'm a 4-cylinder engine, a Honda K24 engine. I have one lambda sensor fitted to my exhaust stream, so I'm going to use my lambda 1 option. If you have a banked engine, V6, V10, V8 engine, you're running 2 lambda sensors, I would recommend to look at lambda average. Now, if you somehow have a lambda 2 wired in and you want to look at your lambda 2 reading, you can point it towards the lambda 2, but in most situations, you'll either be using lambda 1 for an inline 4 or 6-cylinder engine with a single lambda, or on a banked engine with dual lambdas, you'll use your lambda average, taking the average of both banks. I'm going to leave it on lambda 1 right now. The filter is going to be how much we actually filter the lambda sensor reading. Sometimes we can get erratic lambda sensor readings depending on the placement of the sensor and the processing speed of how quickly it's updating things within the link. So if we're streaming it in on the CAN or the internal, it might read a little more jittery if compared to if we're just bringing the lambda reading in through an analog input. Either way, if you're noticing that your lambda is not stable for some reason as you're driving along in steady state conditions, then you can raise your filter up. A filter of 1 or 2 here is sufficient, but you may need to go higher in that filter to calm down your lambda reading so that it's more usable to compare it against the target. We don't want to have an erratic measured lambda reading because it can't do its calculations if this is moving around a ton. Okay, so we have a gauge minimum and a gauge maximum. We're going to leave this at the min and max values of 0.7 lambda to 1.2 lambda. That's how large of a range the gauge here, the display, is going to show. Not really a big deal there. The precision. This is going to be how much it has to see, or I should say in this case, how little it has to see in the difference between our actual target lambda to the measure before it considers a cell point to be tuned in this quick tune feature. So if we have a value here of 0.05, that means if our target lambda is at 1.0 lambda, and as long as our measured lambda is showing either 0.95 to 1.05 lambda, that's a pretty large range, that would consider that cell point to be tuned as long as we're hitting in that range of target lambda. That's not ideal. Let's usually set the precision here to 0.01. That way we're very, very close to the desired target lambda. So in that case, if the target was at 1.0, I'm either at 1.01 or 0.99 for the link to consider a particular cell point to be actually calibrated and tuned with the Quick Tune feature.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.